Today's lesson is Saxon Course 2, Lesson 98, Scale and Scale Factor. So let's start with a review. We just did a lesson on similar triangles. And we know that with similar triangles, the lengths of corresponding sides of similar triangles are proportional. So 6 divided by 2, so this side right here, 6 and 3 are proportional. They're both divided by 2. And you'll notice that this red side, 10 divided by 2, gets this red side on triangle B, which is 5. And then 8, we'll do it in green. This side, the green side, is proportional to the 4 on triangle B, again dividing by 2. So we're going to take this to the next level because it's not just triangles that can be similar. Any shape can be similar, even like the cars that you saw on the first page. So they can all be proportional. And so scale models and scale drawings are other similar shapes, and they're proportional just like the similar triangles were. Scale models and scale drawings are reduced or enlarged renderings of actual objects. Make sure you write that down in your notes. Pause the video. You might also want to write down that reduced means to make it smaller, enlarged means it's made bigger, and a rendering is a drawing or a 3D model. So make sure you pause your video so you can write the information down into your notes. All right, so the scale of a model is stated as a ratio. So if I have two airplanes and I say a model airplane is built with a scale of 1 to 24, the wingspan of the model is 18 inches. And then they're going to ask you how many feet is the wingspan of the actual airplane. Okay. So what we're going to do is we're going to use one of our handy-dandy ratio boxes. You know, we do lots and lots of ratio boxes, but they help us set up problems, so they're very helpful. Definitely something you don't want to skip out on. So with our ratio box, our scale, they told us, was 1 to 24. So our model is that 1, and the object is the 24. So that is our scale. Okay, scale is always a ratio. It can be written as 1 over 24 or 1 to 24. Okay, if the wingspan of the model is 18 inches, they want to know how many feet the actual airplane is. So we're going to use that information. We're going to start with making a proportion. So we're going to do 1 over 24 equals 18 over x. And we're going to make sure that we change our inches to feet when we're done. Okay, so we end up with 1x, or x, equals 18 times 24. Then you're going to figure out 18 times 24. 8 times 4 is 32. 4 times 1 is 4, plus 3 is 7. 2 times 8 is 16. 2 times 1 is 2, plus 1 is 3. 2, 13, 4. So it is 432 inches, but we don't want it in inches. We wanted the answer in feet. So we're going to change our inches by using a unit multiplier. We know that there are 12 inches in 1 foot, so we can cancel out inches. We're going to end up with 432 feet divided by 12. So we're going to do 432 divided by 12. So we end up with 36 feet as our final answer. Okay, so make sure that you're always changing it to the correct dimensions, because you don't want to say 36 inches or 432 feet, because those are totally different numbers. So you have to be really careful of that. Okay, So if you have questions about that, I would definitely start by writing this down. You might even listen to that explanation again because we're going to do a whole lot of problems like this today. Okay, so next one. So it says the blueprints were drawn to a scale of 1 to 24. And I'm going to help you set up this problem, but you're going to have to finish it, so be ready. If the length of a wall on the blueprint was 6 inches, what is the length in feet of the wall in the house? So we've got feet and inches. Our scale is 1 to 24, and we're going to start off with 6 inches. So 1 to 24 is our scale. The blueprint is 6 inches, and we want to know how many feet. All right, so we're going to set up a proportion. 1 over 24 equals 6 over x. I want you to solve that proportion, and then I want you to change it to feet. Use your unit multiplier to help you, and when you're done, then you will put your answer in, and then we'll continue, and you'll check out your work. All right, so you should have done x equals 6 times 24. So 24 times 6 is 144. And that was inches. Now we're going to change inches into feet. Make sure you cross off your inches. So you end up with 144 feet over 12. Divide 144 by 12 and you get 12 feet. So 12 feet is your answer. So we can show a graph of the relationship between the measures of an object and a scale model. On this page, we have shown you a graph of the measures of the airplane and its model. You'll notice that the scale of the model is inches, while the scale of the actual airplane is feet. So over here, you'll see we have inches, and down here, you'll see we have feet. So keep in mind, your model is just the small 3D object of the airplane, whereas the actual size is an actual airplane. So if you look at this, if the model is 1 inch, we know that the actual airplane is 24 inches. So we have 1 to 24. But in reality, the actual airplane is actually going to be measured in feet. So that's 1 inch to 2 feet. Okay? So that's why we have 1 inch and 2 feet right here. If it was 2 inches, it would be 4 feet. 3 inches, it would be 6 feet. You'll notice that it keeps going up on your graph. Okay? Goes up by 2 feet every single time. And so this is how you make a scale on a graph. Okay, you've scaled the airplane model. So we're going to do something similar to that, and we're going to do it for a car model. And they've told us for the car model that 1 inch the scale is 1 to 36. So that's 1 inch to 36 inches. The model, if it's 1 inch, it's going to be 36 inches. But we're going to make a scale or a graph of this, and we are going to turn it to feet. So 36 inches is 3 feet right here. So we're changing our 36 inches and we're going to write 3 feet instead. So 1 inch is 3 feet. So on our graph, we're going to draw a dot at 3 feet. And then if we did 2 inches, it's going to land us at 6 feet. And 3 inches at 9 feet. Because 3 times 2 is 6, 3 times 3 is 9. Okay? And then if we wanted to keep going up, we could do 12 inches. 4 inches is 12 feet. And we can keep on going up. And we use a straight edge to draw our line. And you will notice that the line is always straight because it's always proportional. And we could have not missed so bad. Let's try. A little bit hard to draw it on the iPad. There we go. All right, so we could keep on going up if we wanted it to. So this is one way that you can represent the scale for your comparing your model to the actual size. All right, so let's do a little bit of practice. It says Sophia is molding a model of a car from clay. The scale of the model is 1 to 36. The height of the car is 4 feet 6 inches. What should the height of the model be in inches? So we're going to do a little bit like what we did for the other one. We have a scale of 1 to 36, and the height of the actual car is 4 feet 6 inches, which is technically 4.5 feet. Okay, we also could change that to 4 feet 6 inches, and 4 feet times 12, because there's 12 inches in a foot, plus 6 would give us 48 plus 6, which is 54 inches. So if you wanted to do a little bit less converting, you could put 54 inches right here. And then we want the measure of our model in inches as well. So we've already done our change there. So that makes it a little bit easier. All right, so you're going to write your proportion and go ahead and figure out what the measure of the model is. Okay, so you should have written 1 over 36 equals x over 54. So that would give you, let's see, 36x equals 54. Then divide both sides by 36. Divided by 36. 36 will go into 54 one time. Which gives us a remainder of 18. We could write it, we can just leave it as a fraction or a mixed number. So 18 over 36, which is 1 1/2, because 18 is half of 36. So x is 1.5 inches. Try this one on your own. I'm going to let you solve this one on your own, and when you're done, you'll put in your answer, and then we will review it. All right, it says Brett is carving a model ship from balsa wood using a scale of 1 to 36. If the ship is 54 feet long, the model ship would be how many inches long? So you should have drawn a proportion. So 36x equals 54, and that's feet. And divide both sides by 36. I think we just did this problem, didn't we? In fact, let's look. Yep, we just did this. So we have 1.5 again. But that's 1.5 feet. Do I want 1.5 feet? No, I want inches, don't I? So I'm going to change that to inches. And I'm going to write it as 1.5 feet. And then we're changing it to inches. There's 12 inches in 1 foot. So I've got to do 1.5 times 12. So I add this up, I get 180. And I've got one number after the decimal there, so I need one number after the decimal here. So I end up with 18. And I forgot to cross off my feet. I had inches left, so inches. 18 inches. Sorry. 18 inches is my final answer. All right, let's look at our next page. You need to know that we know what scale is. It's the ratio. A scale factor is the number of times larger or smaller the terms of one ratio when compared to another ratio. So say I have 3/4, and I know that it equals 18 24ths. So what did I do to get there? I could have cross multiplied, or I could have just looked at equivalent fractions. If you multiply 3 times 6, you get 18, and 4 times 6, you get 24. So the scale factor is 6 because you can multiply both those numbers to make your new fraction. So our scale factor is 6. Okay, so I want to try, let's look at this one. We have 3/7. Let's do a practice one first. 3/7 equals 15 over n. So we're going to start by finding what our scale factor is. 3 times what number is 15? Good. 3 times 5 is 15. Whatever I do to the numerator, I have to do to the denominator. So I'm going to do 7 times 5 to equal n. So n is 7 times 5, which is 35. All right, so now I want you to solve these two problems using the scale factor. And remember, scale factor is just like doing equivalent fractions, where you just look for what number you are multiplying by to make it equivalent. Okay, let's see what you came up with. So you should have done 5/7 equals 15 over w. 5 times 3 is 15, so we're going to do 7 times 3, which tells you that w equals 21. All right, then we have x over 3 equals 42 over 21. Oops, I wanted to give myself a little bit more room. Equals 42 over 21. Let's see, 3 times 7 is 21. Now I want to know what number times 7 is 42. I know that 6 times 7 is 42, so x equals 6. All right, here's a new one. It says these two triangles are similar. Calculate the scale factor from the smaller triangles to the larger, from the smaller triangle to the larger triangle. So to do this, you can do the dimension, one of the dimensions of triangle A times a scale factor, which we don't know, we're just going to call it f, and that will equal the dimension of the corresponding line on triangle B. So I'm going to look at this line right here, this blue line, 20 and 25. And I'm going to use f for scale factor. So 20 times f equals 25. So I got the 20 here, the 25 on its corresponding line. And when we solve for f, we find our scale factor. So we're going to divide both sides by 20. So that tells me that f equals 25 over 20. And then I want to know how many times will 20 go into 25. And if you noticed, we write scale factor as a decimal. Oops. 20 will go into 52 times. And 20 will go into 105 times. So our scale factor for this one is 1 and 25 hundredths. All right, so looking at these two rectangles, we're going to do the same kind of thing. We can compare, let's do the blue side, 25 millimeters to the 10 millimeters. And it doesn't matter which corresponding sides you choose, you're still going to get the same answer no matter what. So go ahead and give it a try and see how you do. All right, so you should have written 25 times the scale factor equals 10. We're going to divide both sides by 25 because we want to isolate our exponent, our variable. So f equals 10 over 25. We want to reduce that. Actually, I'm going to change it to hundredths because they said to write it as a decimal, right? So that gives me 40 hundredths. So if I write it as a decimal, it's like this, 4 tenths. Okay, so that's your final answer. All right, it says scale factor is linear. That means the lines work with scale factor. Okay, if we wanted to find the area, it doesn't work straight with scale factor. There's actually something you can do. Just like area is always squared, if you square your scale factors, you will find that you find your area as well, or the difference in the area. The same thing for volume. If you cube your scale factor, you'll find the scale factor for your volume as well. So let's take a look at how that works. It says the smaller of two similar rectangular prisms has dimensions of 2 centimeters by 3 centimeters by 4 centimeters. The larger rectangular prism has dimensions of 6 centimeters by 9 centimeters by 12 centimeters. And it says, what is the scale factor from the smaller to the larger rectangular prism? So we're going to find out the scale factor. So we're going to compare this side 2 to 6. So we've got 2 times the scale factor equals 6. Divide both sides by 2 to isolate your variable. So F equals 3. So your scale factor is 3. Then it says the area of any face of the larger prism is how many times the area of the corresponding face of the smaller prism. Well, to figure this out, what you're going to think about is you're going to take your scale factor, and you're going to square it. So it should be 9 times the area. So if I took the smaller triangle and I did the area of, let's say, this front face right here, okay, and I did 2 times 3, and I got that the area was 6 centimeters squared. And then I did the area of this front face on the larger triangle, the corresponding face. So I did 6 times 9 equals 54 centimeters squared. 6 times 9, which is what we said right here, 6 times 9 equals 54. So the nice thing about doing that is, say you have two similar shapes, 3D shapes, and they want you to compare the area. You only have to find the area of one, and then if you multiply that times the squared scale factor, you find the area of the other shape too. It's kind of cool how it all works together. There's always patterns in math everywhere you look. So it says the area of any face is how many times? Our answer is 9 times, which is 3 squared. Okay, so the volume of the larger solid is how many times the volume of the smaller solid? Well, we learned that we're supposed to cube it because it's volume. So 3 cubed is 27. So according to the rule, it should be 27 times as much. All right, so let's give it a shot. The volume of the first one is 2 times 3 times 4. 2 times 3 is 6 times 4 is 24 centimeters cubed. All right, the second one would be 6 times 9 times 12. 6 times 9 is 54. 54 times 12, let's see, 8, 10, 4, 5, 8, 4, 6. So it's 648 centimeters cubed. So now my question is that true? Did it actually work? Because, you know, math is all about problem solving. So we're just going to work it out. Is 24 times 27, 648. 7 times 4 is 28. 7 times 2 is 14, plus 2 is 16. 2 times 4 is 8. 2 times 2 is 4. Add them together, I get 8, 14, 648. So it's the same. So it's 27 times. All right, that's the end of this lesson. See how you did. If you don't like the score that you got on this, make sure that you let me know so that I can reset it for you. And you are welcome to do it again. This is a little bit of a tricky one. It took me a couple times going through it to really fully comprehend everything that was in there. And so don't feel bad if you need to go through it a couple times to get to where you understand it too. I'm happy to reset it as many times as you like.